We're on problem 24. Use the solution procedure below to answer the question that follows. Which of the following is a major flaw in the procedure shown above? So let's look for some flaws. So the way I always like to do is just think about how I would have done it. So if I started with minus 3x plus 25 is equal to 4, the first thing I would do is subtract 25 from both sides of the equation. So I would take a minus 25 from the left-hand side, and then a minus 25 from the right-hand side. And it looks like that's what the person did. They took a minus 25 there, and they took a minus 25 just like that. And then he said, okay, well, that's the same thing as minus 21. So then you would get minus 3x on the left-hand side is equal to minus 21. I have a sense that I already know what the major flaw is. He's doing two steps, and he's not writing a nice, clean equality, and he's trying to skip steps. And my guess is that he's going to get confused. So then you end up with minus 3x on the left-hand side, right, because these cancel out. Minus 3x is equal to minus 21. So you get that. So you get that right there. So you get minus 3x is equal to minus 21, and then you divide both sides by minus 3, and you get x is equal to 7. So the guy got the right answer, however he or she may have done it. But this is a little confusing because then divides by 3, but this divide by minus 3, which you do have to do. You have to do to both sides of this equation. I just don't see where he or she did it. Maybe somehow you just divided by minus 3 randomly. I don't know why. They didn't really understand the notion of an equality on an equation, that you have to do the same thing to both sides of this equation. So let's see what the choices are. The concept of the opposite number is confused with subtraction. No, not really. The equal sign is used to connect expressions that are not equal. That sounds about right, because this expression, that expression, and this are equal. We got minus 3x plus 25 minus 25, which is just minus 3x. That does indeed equal 4 minus 25 or minus 21. But that does not equal minus 21 divided by minus 3. So this looks like my answer. Let's look at the other choices. The solution contains an error in the arithmetic of signed numbers. Oh, no, the solution is arithmetically correct. D, the order of operations between subtraction and division is reversed. So I really don't see that. So my choice would be B. The equal sign, this right here, does not equal this right over there. Next problem, 25. Use the diagram below to answer the question that follows. So let's see, they're extending by 1 in each direction. They're kind of creating this triangle. If the pattern continues, how many more small squares are in figure 100 than are in figure 99? So let's think, every time we increment it, how many squares are we adding? When we go from 1 to 2, how many did we add? We added 1, 2 squares. We went from 2 to 3, how many did we add? We added 1, 2, 3 squares. We went from 3 to 4, how many did we add? We added 1, 2, 3, 4 squares. Those are the 4 that we kind of layered over the 3 right there. So when we go from 100 to 99, so when we go from 99 to 100, we're going to add 100 squares. We're going to add 100 squares. When we go from n to n plus 1, when we go from n to n plus 1, we're adding n plus 1 squares. So you go from 99 to 100, you add 100 squares, or there are 100 more squares in the 100 figure than in the 99 figure. Next problem. All right. Problem 26. Use the table below to answer the question that follows. Okay, they have an x-axis, and then we have a y-axis. And what do they want us to do? Each number in the table above represents a value of w that is determined by the values of integers x and y. For example, when x equals 2, y equals 1, w is equal to 21. If the pattern continues, what is the value of w when x is equal to 20, and y is equal to 8? So let's see if we can get a sense of what w is. So w, if you remember your functions, w is a function of, I could write it like that, is a function of x and y. That might confuse you. It may or may not. We just have to figure out what this function is. So if you look at this pattern, every time we look at here, we go, so this is 0 to 8, and then we go from 8 to 16. So this is we're adding 8 every time we go to the right. We're adding 8, right? It looks like we are. And then as we go up, what are we doing? So this is plus 8. This is plus 8. So for example, this right here is 4 times 8. This is 3 times 8. So it looks like W is equal to 8 times X. But then as you go up, what happens? As you go up, when you go up, we're adding 5 every time. Is that throughout the whole table? Yeah, sure. 37 plus 5 is 42. We add 5 every time. And we start here at just 8 times x, and then when y is 0, and then we add 1 times 5, 2 times 5. Looks like it's 8x plus 5y. That's what w is, right? And let's verify it. If we pick the point 3, 2, so that would be w is equal to 8 times 3 plus 5 times 2. 5 times 2. So w is equal to 24 plus 10 is equal to 34, which is indeed what it equals. So we found our function of x and y, and what are they asking? The pattern continues. What is the value of when x is equal to 20 and y is equal to 8? Well, in that situation, w is equal to 8 times x, which is 20, plus 5 times y, which is 8, which is equal to 160 plus 40, which is equal to 200. And that is choice B. Next problem. Problem 27. The function r of x gives the remainder when a whole number x is divided by 10. When a whole number, okay. Which of the following graphs represents r of x? So when you take something on the x-axis and divide it by 10, r of x should be its remainder. So when you take 5 divided by 10, the remainder is 5. So it should plot out to be a 5 right there. When you take 10 divided by 10, your answer is, well, the answer is 1, and your remainder is 0. So that looks right. And then 15, the remainder is 5. So those look right. Let's see. When you have 1 divided by 5, 1 divided by 10, the remainder is 1. So that looks right. This graph A looks pretty good. If you take, 20 divided by 10, the remainder is 0. If you take 30 divided by 10, the remainder is 0. If you take 29 divided by 10, the remainder is 9. It's right there. 19 divided by 10, remainder is 9. 9 divided by 10, remainder is 9. This one looks pretty good. Let's see what the other ones do. So here, let's see. When I take 10 divided by 10, the remainder should be 0. This should be a 0 right here, but they have the remainder being 10. So this is wrong right off the bat. And then here, the remainder when a whole number x is divided by. This is a whole number, right? Whole number x. Here, they're doing it for essentially all of the real numbers, right? This would be true if they said any real number, but they're including fractions because they're filling in the gaps right here. So C and D are not dealing with whole numbers. So our answer is definitely A.